Hi students, today we're going to continue talking about inverse functions. The last thing we looked at was how to determine whether or not two functions are inverses, but we had to be given both of the functions. Right now we're going to look at how to find the inverse of a function, and it's a relatively straightforward process. Let's take a look at it. To find the inverse of a one-to-one function, first, we write out the function as y equals whatever the function is. Then we interchange or switch x and y. And then we need to solve for y in terms of x, if possible. And lastly, the equation we get is the inverse function. Let's look at a couple of examples that we've already seen before. Let's start. We'll find the inverse of f of x equals 3 minus 4x. So the first thing we need to do is write the function as y equals that function of x. So instead of f of x equals 3 minus 4x, we're going to write y equals 3 minus 4x. Then we need to switch the x and the y. So it's going to be x equals 3 minus 4y. And once we're here, we need to solve this equation for y in terms of x if possible. It generally should be possible so long as we're dealing with a one-to-one function. There are some exceptions, but those are the ones that have very complicated equations that we probably will not be dealing with. So we need to solve this equation for y. We need to get the y alone. So I'm going to subtract 3 from both sides. If I do that, that gives me x minus 3 equals negative 4y. And then I'm going to divide both sides by negative 4. This gives me y equals x minus 3 over negative 4. And the resulting equation is the inverse function. So this equation, this expression actually, is what our inverse function is going to be. So we have f inverse of x is x minus 3 over negative 4. This is a perfectly fine final answer. There's another way to write this that looks a little bit nicer. Instead of having a negative 4 on the bottom, we could have a positive 4 by multiplying the top and bottom by negative 1, or taking the opposite of the top and bottom. If we did that, we could also write our inverse function as 3 minus x over positive 4. Either of these is fine. I think the second one looks a little bit nicer because dividing by a positive is better than dividing by a negative, but really either one works as the inverse. Let's do another one. Let's find the inverse of f of x equals x cubed plus 1. Again, we're going to start by writing the function out as y equals x cubed plus 1 instead of f of x equals x cubed plus 1. We will interchange the x and y, so we'll write this as x equals y cubed plus 1. And then we need to solve for y, so we can subtract 1 from both sides. That gives us x minus 1 equals y cubed. And if we have y cubed and we need to turn that into y, we can take the cube root of both sides. If we do that, the cube root of y cubed is y, and the cube root of x minus 1 is just the cube root of x minus 1. So once we've solved for y, this is the expression that represents our inverse function. So f inverse of x is the cube root of x minus 1. The reason this works in giving us the inverse function is because remember that the inverse function is effectively switching the output and input values. It's switching the domain and the range. And so this step where we interchange x and y is switching the relationship. And when we do that, we just need to then get y alone, so we've got a nice formula for that function. In the next video, we're going to look at the relationship between the graph of a function and the graph of its inverse function.